There's one feature of TypeScript that day-to-day TypeScript developers take completely for granted. But if you're coming to TypeScript from another object-oriented language like C# or Java, and you're learning TypeScript, then this will actually blow your mind. It's called structural typing. Let me explain what it is. So there's two main ways that statically typed programming languages do type checking. There's nominal typing and there's structural typing. In nominal typing systems, the compatibility between types is determined by the explicit type declaration. And this is what a language like C# uses. So if I create a type in C#, let's say I create a record type, but this could be a class or a struct or any other type, then this record exists in a specific file on disk, and in the context of your wide application, this record exists in a specific location. In C#, this is done by giving it a namespace. So I might have this person record, and that exists of a namespace of my namespace.models.people. I'm just making this up, but it's fairly typical of how people create types in C#. Now, if I wanted to use this person record somewhere else in my code, then I need to access that namespace. There's no other way. So let's say I create a second file here, and we create a function in that file that takes in the person record as an input argument. Well, in order for this to compile, we need to reference that my namespace.models.people namespace. And additionally, if that person record was stored in an external library somewhere, then we'd actually need to import that external library, either by importing it from another project or importing it from NuGet. Now, this is just the way that type references work in C# and also in Java, and it's called nominal typing. TypeScript, on the other hand, uses something a bit more clever than this, called structural typing. With structural typing, the compiler actually looks at the shape of the types themselves to determine whether two types are equal. So in TypeScript, it doesn't matter where the type is defined or what it's called even. What matters is the shape of the type, its structure. Let me show you an example. Here we've got a person type, but this time in TypeScript, and we're going to use that to create a variable called John. But notice something interesting. Our greet function doesn't actually reference the person type at all. It just specifies the shape. So an object with a name property, that's a string, and an age property that is a number. And yet, the TypeScript compiler is perfectly happy with us just passing John into this greet function, because John matches that expected shape. This is structural typing in action. The compiler doesn't actually care that John is explicitly typed as person. It only cares that the same structure is there as the expected input for that function. So let's go a little bit further with this example, right? Here's another example where we've created a completely unrelated type called animal with the same structure as person. Now it has a name and an age as well. And guess what? We can pass an instance of animal into that greet function as well, and it works perfectly fine. Because TypeScript doesn't care about the names of those types, it only cares what the type looks like, which properties has it got, and what's the shape of it. This is why structural typing feels so flexible and so powerful. We don't need to be importing a library that contains that person class to be able to use this. We just need to know what shape the data inside that person class is, or a subset of it, the bit we care about. And for day-to-day TypeScript developers, this just feels natural. You might not even think about it, but for someone coming from a nominal typing background, this can be a real game changer. And there's one more cool trick that I want to show you as well in TypeScript. So here's a function that accepts any object with a name property. That's all it cares about, right? But when we pass in this random object that has extra properties like age and location, TypeScript doesn't actually mind. It only checks that the required name property exists and it has that correct type. So this is working a lot more like an interface might work in C# or Java, just without all of that messy interface declarations. And this is known as duck typing. You're basically saying if it looks like a duck and it quacks like a duck, then TypeScript says, sure, that's a duck, we can use it. So what's the takeaway? Well, structural typing makes TypeScript really, really versatile and also really forgiving. It lets you focus on what your data looks like rather than worrying about where it came from or what the types are actually called. And for anyone building modern JavaScript applications, that makes TypeScript feel like a seamless extension of JavaScript's dynamic nature while still giving you all the benefits of static typing. So you get a lot of the benefits of the dynamicness of JavaScript, but without rigidly tying you into a nominal typing system. If you're coming from a nominal typing background, structural typing might take a little bit of time to get used to, but once you get used to it, it is really one of those features that just makes you say this is awesome, right? So thanks for watching. If this video helped you clarify structural typing for you, then don't forget to like and subscribe to Train to Code here on YouTube. Click the notifications so you don't miss my next video. My name's James Charlesworth, and I'll see you in this one on your screen now.